For real, like that kind of sucked.
So, horizontal line segments pieced together to form a function. So it's not bad because it's specifically horizontal line segments. They're also known as ceiling functions and floor functions.
Wait, isn't that like a piecewise function?
Specifically horizontal line segments. Piecewise aren't always horizontal. So this is a type of piecewise. All right, so we'll jump right into a word problem. Electrician works at a job site at a rate of $40 per hour, right? Or any portion of an hour. In other words, he will charge you $40 as soon as he comes up to the first hour, and then another $40 for the second hour. Graph the amount the electrician charges C in dollars as a function of the number of hours he works. All right, and then how much did he charge for working 3.5 hours? All right, so what that's telling us is that he's going to pay. You're going to pay $40 for that first hour. All right, so 40 is right here. I'm just going to label everything just so I have it. All right, so we know that we're going to have to pay $40 the minute he walks through the door. All right, now if you haven't worked any hours, so at 0 hours, you wouldn't be expected to pay any money. All right, so I wouldn't plot a point at 0, but for the next infinitesimal quantity after 0, I would plot a point. So how do I represent that? If I want to get really, really close to the x value of 0, open circle. So I'm going to put an open circle at 0, and then each of these points would exist along that horizontal line until we get to 1. Once we hit 1, once we get past 1, we're going to jump up to the next price point. All right, so it's $40 an hour or any portion of an hour, and then after that you're going to pay another $40 for the second hour, so we're going to be up to $80. All right, but at hour 1, am I at $80? No, but I'm really, really close to it. I'm really close to $80. I'm really close to the coordinate 1, 80. So I'll represent that with another open circle. And then I'm going to plot points that'll get me really, really close. Or it'll get me all the way to 2. And then I'll plot points that'll get me really, really close to the next price point. All right? Which would be what? 120. So open circle at 120. All right, so if we're in the third hour, so basically anything beyond 2 hours, we're paying for the 3-hour rate. All right, so we're in the first hour, we're paying for the first hour. All right, we're in the second hour, we're paying for the second hour. We're in the third hour, we're paying for the third hour. So if you're at 2 hours and 37 minutes, you're still paying for 3 hours. All right, so you're committed to that. All right. So then the next one would be what? What's the next price point? 160. All right, it's the same deal. If the person works for exactly 3 hours, I'm still going to pay the 3 hour price point. I'm still going to pay $120. But if they work for 3 hours and half a second, I'm hopping up to the 160 price point. All right. So the way, again, I represent getting really close to that mark of 3, 160 is by putting an open circle there. And then we're showing that we're getting all the way to 4, 160, because if they work for 4 complete hours, not a second more, we're still living at that $160 price point. The final price point would be what? 200. All right, so that's what a step function looks like, and you can see it looks like steps, so that's kind of why that's the same, yeah.
Oh.
So how much you paying if the person works for 3.5 hours? $160.
Good job.
All right. Sometimes they write a step function as a piecewise. I mean, it could be sort of a pain to do it that way, because really, if you think about it, I mean, we have 1, 2, 3, 4, 5 steps here. That would equate to 5 horizontal lines. So if I wanted to write this as a piecewise function, and I think I do. Oh, I did that. I've been doing that all day. What I'd have to write would be, and this is something you'll need to know how to do, so you might as well write it down. Actually, let me just get the notation here, because I don't think it's F. C. And it is a function of the number of hours you work. So I'll call hours X. But the other variable is C. It says C of X. We'd be looking at 40 as the first price point, then 80, then 120, then 160, and then 200. If. So what's the condition for the 40 price point? X is greater than 0, but less than
1
or equal to 1. So X is between 0 and 1, including the 1, not including the 0. All right. What about the next price point? Greater than 1, less than or equal to 2. The next one? Greater than 2, less than or equal to 3.
Does it matter? Actually, never mind.
Greater than 3, less than or equal to 4. And the last one?
Greater than 4, less than 4.
Perfecto. All right. I mean, not terrible in terms of writing the piecewise, but it's a lot to write. And there's a lot to keep track of, because, I mean, the one good thing is that there's some consistency, that all your less thans are on the left-hand side, all your less than or equals are on the right-hand side. So that's good, but you still gotta write it all. That's the least desirable component of all of this. All right. So it's a thing that happens. That doesn't mean that it's enjoyable. All right. But in terms of graphing, it's not bad, because the recipe is really there. When you're given it in piecewise form, it's really just telling you to graph the line y equals 2, but only between 0 and 3. Graph the line y equals 5, but only between 3 and 5. and graph the line y equals -4, but only between 5 and 10. So we might as well just bang that one out real quick. All right, so I'm going to label my axis, though. You don't have to do it if you don't want to, but I'm just doing it so I can easily reference things. And I need to go up as high as 5. And down as low as -4. All right, so again, we're looking at y equals 2 if x is between 0 and -3, 0 and 3. All right, so the horizontal line y equals 2 gets a closed circle at 0 and an open circle at 3, and it's horizontal. So draw a little line segment going there. Then the line y equals 5 if we're going from 3 to 5. So closed circle on the 3, open circle on the 5. And the last one, y equals -4, only happens between 5 and 10. Closed circles on both ends. All right. Now you can see this is a different type of step function, but it still satisfies the conditions. All right. Pieces of horizontal line segments put together to form a function. All right. That's true. The issue is it doesn't look like a staircase like the last one. All right. So it doesn't feel very nice, but it's like the video game where you have those like floating things that you gotta jump to. Yeah. Just think of it that way. Those kind of stairs, like crazy stairs. All right. So just some follow-up questions and saying what's f of 2.7. So we find 2.7 on the graph. 2.7. We're still in the black part of it. So we're still on 2. A good graph makes these kind of questions really easy. F of 5. We're on the blue part, which is at 5. F of 3.5, we're still, oh wait, sorry, F of 5, we're on the red part. I looked at, I saw this number and I just went after it like an animal. F of 5, we find 5 down here and we look, and you see we're at -4. 3.5, we're on the blue part.
How do you know if it's down there? Like, opposite not there? Okay, never mind.
F of 0, we're still on the black part, so we're still at 2. For the domain again is all values of x for which the function exists. All right, so 0 to 10, exactly. So x, oh, well, didn't say which way to do it. So interval notation is the most convenient way to do it. It's nice and easy. So we're going from 0 to 10. Would that get brackets or parentheses? Brackets. Brackets include, parentheses do not. All right. Now for the range, well, it's not an interval of values. We're not including all y values between -4 and 5, right? Because we're skipping really everything between -4 and 2, and then everything between 2 and 5. So what values of y are the only values of y that exist for this function? -4, 2, and 5. They're specific y values. So we indicate that with the squiggly brackets. All right. So that's kind of, it's good and bad, I guess, with piecewise functions. and step functions. Step functions specifically, it should be pretty easy to identify what your range is, because you're just looking at the y values for which there is a graph. Right? It's very easy to pick it out. For other types of piecewise functions where it's not made up of specifically horizontal line segments, it's a different story. But the domain, really, you're just making sure that you're covering every x value. So you get to the 3 here, you say, well, we're not including the 3 for the black part of the graph. But then hopefully you say, oh, but wait a minute, the blue graph is picking that up. Right? So we're getting 3 on the blue part of the graph. Then you get to this one and you say, oh, we're not getting a 5. Oh, but wait a minute, we're picking that up with the red part of the graph. All right, and we get all the way to 10. So hopefully, if you reason it out that way, you won't run into too much in terms of difficulty.